All right, for example number 2, we have a group of friends, Gracie, Anna, and Whitney. We want to know how many ways can they arrange themselves to stand in line for the movies. Okay, they're standing in line. So we've got 3 people to choose from, and they're all going to stand in line, so there's 3 of them. Now, since we're standing in line, first, second, and third, order matters. So this is going to be a permutation. So we are going to do permutation because order matters. We have 3 people to choose from, and we are going to take all 3 of them. Okay, so it's 3 permutation 3. So if you're using the formula, you would do 3 factorial over 3 minus 3 factorial, which is 0 factorial. 0 factorial is just 1, so we have 3 times 2 times 1, so 6. Now, you can do this in your calculator. Let's see if I can get the calculator to behave. Give me half a second here. This calculator, clear this out. Nope, does not want to behave today. Let's try it here. There we go. Okay. So 3 permutation 3. So we're going to click 3 in the math menu, go over to probability, down to permutation, and 3. It will work on the TI 30s as well. You put in 3, you go to the probability menu, arrow over till you get permutation, and then hit your other 3. So you get 6 as well. All right. Another way you can think about this. This is method number 2. Sometimes I think about them standing in line, actually, right at the line. So how many people do I have to choose from for the first spot? Well, I have 3 people to choose from, okay? And let's say I pick Whitney, just because. How many people do I have to choose from for the next spot? Well, there's 2 of them, okay? And let's say I pick Gracie. Now, if Whitney and Gracie are already in line, that means the only person left to fill is Anna. So it's 3 times 2 times 1, which of course is the same thing. So you can also kind of think about filling slots if that makes more sense to you. All right, how many ways can you choose 2 of them to ride in a car together? Okay, so 2 of them are going to go in the car together to, I don't know, do something. And we want to choose which ones. Now in this case, we're just picking 2. It doesn't matter what order. They're just both getting in the car. So this is going to be a combination. We have 3 people to choose from, and we're taking 2 of them. So if we're using the formula, it's 3 factorial over 2 factorial, then times 3 minus 2 factorial, which is 1 factorial. Okay, so that's going to be 3 times 2 times 1 is 6. On the bottom, I have 2 times 1 times 1, which is 2. So there are 3 different ways to choose these people. Again, both calculators will do this for you. You don't have to use that formula. You can do 3, and in the math menu, go over to probability, and go down to combination, and 2. Again, TIs will do the same thing. Just hit the probability button. Okay? All right. Number 3, a class of 18 fifth graders is holding elections for class president, vice president, and secretary. And how many different ways can these officers be elected? We're assuming the same person can't be all 3 of those. So in this one, since these are different offices, president, vice president, secretary, order matters. So we can think of it as a permutation. Okay? We have 18 people to choose from, and we are choosing 3 of them, president, vice president, secretary. So it's 18 permutation 3. So you can go ahead and do that on your calculator. I'm not going to pull the calculator up this time, just do it real quick on there. So 4,896. The other way you can think about it is filling the slots, okay? President, this is president, vice president, and secretary. So if we pick president first, we have 18 people to choose from. And then we pick vice president. Well, we can't pick the person we already picked for president, so now there's only 17 to choose from. And then for secretary, there's only 16 left to choose from. This filling slots method only works for permutations, okay? But it is another way to think about it. It's going to get you the same answer. All right, the cafeteria is serving the following vegetables for lunch. We have carrots, green beans, lima beans, celery, corn, broccoli, and spinach. Is that 7 things? 1, 2, 3, 4, 5, 6. Okay, so we have 7 different items here. I don't know, that might be important. Josh wants to order a vegetable plate with 3 different veggies. how many ways can his plate be prepared? Okay, so he just wants a veggie plate with 3 different things. It does not matter what order they go on his plate. He just wants to pick them. So this is a combination. We have 7 vegetables to choose from, and he is going to get 3 of them. Okay, so if you're using the formula, it would be 7 factorial over 3 factorial times 4 factorial, or you can just put it in your calculator. 7 combination of 3, and we get 35 different ways to make this plate of veggies.